Good morning, students. Dear students, in continuation with the video lectures on laws of motion, we are proceeding towards the part 2 of the video lecture. And in the previous video, that is in part first, we had discussed about motion. We had discussed motion dynamics. We had discussed, after that we had discussed force definition, role of force in motion. Then we had discussed about inertia, and then we had discussed about types of inertia. These things we had discussed. In this, we had also discussed about Aristotle's fallacy. Fallacy and Galileo Galilei. These things we had discussed. That is the introduction part of the laws of motion, and in that we had discussed about these things. We recapitulate, we revised these things which you had studied in the previous classes. Now, today's video, we will discuss about Newton's laws of motion. What are the different laws of motion we will discuss? So today we will discuss about the Newton's first law of motion, and how Newton's first law of motion correlates inertia, and then about momentum. So in today's video we will discuss about Newton's laws of motion. Newton's laws of motion. After that, we will discuss about Newton's first law of motion. Newton's first law of motion. Then we discuss about how Newton's first law of motion correlates inertia. This thing we will discuss. After that, we will discuss momentum, and then variation of momentum. All these things we will discuss in today's video. So first we will discuss Newton's laws of motion. So whatever the observations made by Galileo Galilei after falsification of Aristotle, the scientist Sir Isaac Newton, he made systematic study of motion, and extended the views of Galileo. And from here he arrived with three laws of motion. He arrived at three laws of motion. After that, he arrived on three laws of motion. That three laws of motion are called as Newton's laws of motion. Newton's laws laws of Newton's laws of motion. That three laws are called as Newton's laws of motion, and this Newton's laws of motion are very useful for studying mechanics. For studying mechanics, these Newton's laws of motion are very much useful. So we will discuss about, because this Newton's laws of motion, for dynamics of motion, this Newton's of laws of motion are very much important, and these are the boon of the dynamics of motion. So we will study about Newton's first laws of motion. Newton's first law of motion. We will study about, first we will study about Newton's first law of motion. Newton's first law of motion. What is Newton's first law of motion? Then, as you all know, that Newton's first law of motion is the law of inertia, and states that if a body is at rest, it always tries to be at rest, and if the body is at motion, then it always tries to be in motion until and unless an external force is not applied on it. Means any body in this universe does not want to change its state by itself until an external force is not applied. So the statement of Newton's first law of motion: every body continues in its state of rest or of motion in a straight line unless it is compelled by some external force to change that state. If a body is at rest, it tries to be at rest, and if a body is in motion, it always tries to be in motion unless and until it is not compelled, it is not forced by some external force or external forces, until and unless an external force is not going to be applied on it. Now, what is the meaning of state of rest or motion in a straight line? The state of rest or uniform linear motion state of rest or uniform linear motion shows that the body has zero acceleration. It is quite simple to understand, students. If a body is at rest, means it is not changing its position with the, or its velocity is not changing, means here acceleration is zero. Or if a body is moving with uniform speed of 3 meter per second, means continuously the body is moving with 3 meter per second, this is the uniform speed. this is the uniform speed. It means that here also the acceleration is 0. Means until the external force is not applied, the acceleration is always 0. For non-zero acceleration, for non-zero acceleration, for non-zero acceleration and external force must be applied. For non-zero acceleration means either it changes its state of rest or it's change its uniformity. For both the purposes you have to apply the force. If you are applying the force here, if you are applying the force here, then the acceleration become non-zero. The acceleration become non-zero and body starts accelerating. I am elaborating with certain examples. Newton's first law is categorized into 3 parts. Newton's first law, it is categorized. It may be categorized into 3 parts. First part is what? Suppose a book is placed on a tabletop. A book is placed on a tabletop. This is a tabletop, and we had placed a book on the tabletop. Then here is the downward force. Due to Earth's gravity, and it is equal to mg, and here the normal reaction R, and both the forces balancing each other, R minus mg is equal to 0. So net force is equal to 0 because both the forces are going to cancel each other. So there is no net force here, and here acceleration is equal to 0 and body remains at rest. The second thing is a ball rolling on the floor. The second case is a ball rolling on the floor. This is the floor, and rolling of ball on the floor. Rolling of ball on the floor. Now look at here. If there is ball is rolling in this direction, if frictional force, there is some friction in this surface, the surface is not smooth, then after, if F is equal to, that is friction is equal to 0, then the ball continues its uniform motion, and if F is not equal to 0, then ball stops after traveling certain distance, after traveling certain distance, after certain distance. But if we apply an external force here, then the uniformity in the motion is going to be changed. This uniformity is going to be changed, or this uniformity is going to be varied. So this is the second case of uniform motion. And the third one is about the direction. Means a body does not changes its direction by itself. A body does not changes its direction by itself. A body does not changes its direction by itself. For changing the direction of the body, an external force is applied. Suppose I am taking an example that moon is revolving around the earth. Suppose this is earth and the moon is revolving. This is moon. Means there is a force of attraction between earth and moon which compels moon to change its direction continuously. The moon is not by its own changing its direction, but the force of attraction between the earth and the moon is compelling the moon to change its direction continuously. So nobody in this universe can change its direction by its own until an external force is not going to be applied over it. Now we will discuss how Newton's first law of motion defines inertia. Now dear students, we will discuss how Newton's first law defines inertia. So according to Newton's first law, you know that every body continues in its state of rest or uniform motion unless an external force acts upon. This is the Newton first law, and Newton first law continues to be in a state of rest or uniform motion unless an external force acts upon it. It shows that a body does not change its state by itself. A body does not change its state by itself. And this is what? This is inertia. This is the inertia. This is the fact of inertia. Means Newton first law is inspired by inertia. Means if there is no inertia, then Newton is not able to give the first law, his first law. Without inertia, Newton was unable to give the first law. Now, this is about Newton's first law and how Newton's first law defines inertia. All we had discussed. Now, we are going to discuss about a small thing about momentum. You had already studied about momentum in class 9th also. Here I am also giving you a little view about momentum. And momentum is nothing. Momentum is quantity of motion. Quantity of motion possessed by the body. Quantity of motion possessed by the body means it defines about the quantity of motion, not quality of motion. Quality of motion is defined about Newton's first law had defined the quality of motion, but momentum defines the quantity of motion, and based on this there is Newton's second law. So quality of motion is defined by Newton's first law and quantity of motion is defined by Newton's second law, which is based on momentum. And it is nothing, it is product of mass m and velocity. Mass m and velocity. It is the product of mass m and velocity v. So momentum p is equal to mass into velocity. Its SI unit of momentum is kg meter per second. CGS unit gram centimeter per second. Dimensional formula mLT minus 2, and since it is the product of mass and velocity, so velocity is a vector quantity, so momentum is also a vector quantity. Momentum is also a vector quantity. Now, this is all about the momentum, mass into velocity. Means since it is dependent on mass, so we can say that if there is a heavier body, then it has more momentum, and if it is a lighter body, then it has less momentum if both have the same or equal velocity. So it gives the quantity of motion possessed by the body. Now we will discuss about variation of momentum. Variation of momentum. Variation of momentum. First case. Let two objects having mass m, both have mass m, and moving with velocities v1 and moving with velocities v1 and v2, with v1 greater than v2, with v1 is greater than v2, v1 is greater than v2. Then momentum of the first body mass into velocity v1 and momentum of the second body is mass into velocity v2. Now taking the ratio p1 upon p2 is equal to mv1 upon mv2, it will cancel out and it becomes v1 upon v2. So we can say that momentum is directly proportional to velocity, and if we draw the graph, on y-axis we take momentum and on x-axis we take velocity, and since p is directly proportional to velocity, so the graph will be a straight line where mass is equal to constant. Mass is equal to constant. Now the second case, two different masses are moving with same velocity. Two different masses. Okay, second. Two different masses are moving with same velocity. Let the heavier body of mass m1 and lighter body of mass m2 moving with velocity v, then we can say that p1 is equal to m into m1 into v and p2 is equal to m2 into v, and hence p1 upon p2 is equal to m1v upon m2v. p2 we cancel out, and here we see that p is directly proportional to m. So on plotting the graph, momentum on one axis and mass on other axis, then we get a straight line where velocity is equal to constant. Here m1 is greater than m2, so p1 is greater than p2. And the third case, case 3. Third case is if both the bodies has different masses and different velocities, but their momenta is same. If both the bodies have different masses and different velocities, but their momenta, plural of momentum is momenta is same. Then we can say that P1 is equal to P2 is equal to P, which implies that m1 v1 is equal to m2 v2, and taking its ratio you will get m1 upon m2 is equal to v2 upon v1, or you can say that mass is inversely proportional to velocity. So the graph, if we consider velocity on one axis and mass on the other axis, then the graph will be rectangular hyperbola. If x is inversely proportional to y, then the nature of graph will be rectangular hyperbola. This is the nature of graph for inverse relation, and it is a rectangular hyperbola. So we can say that if m1 is greater than m2, so v1 is less than v2. For same momentum, if m1 is greater than m2, then v1 is less than v2. If m1 is less than m2, then v1 is greater than v2. Vice versa. Okay, students. So that's all for today. And in tomorrow video, we will discuss about Newton's second law of motion, which defines the momentum and then force. It is based on momentum. Newton's second law of motion is based on momentum, and on that basis we define the force. So that's all for today, students. Have a nice day. Take care.